All right, so the triangle inequality, here we go. We just did the explore activity, and we saw that in any triangle, the longest side of a triangle still has to be shorter than the sum of the other two sides. Otherwise, you can't even make a triangle. So right here, it says in order for three segments to actually make a triangle, a special relationship must exist among their lengths. That special relationship is this. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if you add two sides of a triangle together, and it adds up to more than the third side by itself, that means it can form a triangle. If that's not true, then it cannot form a triangle. So that includes being equal to. If the two shorter sides add up to equal the longest side, not a triangle. They have to be more than the longest side by itself. So, like I said, quick lesson today. Is it possible to form a triangle with the given side lengths? If not, explain why not. So, 9 plus 12, what does that add up to? 21, okay. Is 21 greater than 18? Yeah, all right, so 21 is greater than 18. This is page 387. Nine plus 12 is 21, so 21 is greater than 18. 12 plus 18, what does that equal? 30. Is 30 greater than 9? Yeah. 9 plus 18 equals 27, which is definitely greater than 12. So basically, we've added together all three numbers, or all ways you can add two of those three numbers together, we've done. And every single time, the two numbers added together to equal more than the one number that was by itself. And so because the sum of each pair of side lengths is greater than the third side length, sides with lengths of 9, 12, and 18 centimeters do form a triangle. Now, this was overkill. You don't need to test all pairs of possibilities. The only ones that you actually need to test are, which ones do you think? Which ones do you think would be the most important to check? Which one of those three is really the only one that we need? The first one. How come? Yeah, 18 is the longest, is the biggest number out of those three. The only thing you need to check to make sure that three lengths can form a triangle is if the two shorter add up to be more than the longest one. Because any other combination, if this is true, then those have to be true, no matter what. So as long as the two shorter ones add up to more than the longest one, that means it can be a triangle. So this next one, and that's exactly what's happening here. We only need to check the two shorter ones to add up to make sure they equal more than the longer one. What's 3 plus 5? 8. So is that greater than, less than, or equal to? Equal to. All right. So this basically fails our test because it says the sum of one pair of side lengths is not greater than the third side. It's actually equal to it with side lengths 5, 3, and 8 inches. So sides with 5, 3, and 8 inches do not form a triangle. It would basically look like the first thing we did in the warm-up where everything just kind of like laid and turned into one segment. So it doesn't actually make a triangle, it just makes a segment on top of a segment. This is the segment addition postulate, basically. All right. Try those two. Do those two real quick on your own. And you don't need to do the explanation. The explanation is they're either greater than or they're not greater than the longest side. So you can just write a yes or no real quick on these ones. And actually, these are quick enough that I think we can just answer these real quick. A, yes. The longest length is 6. 2 plus 5 is 7. 7 is more than 6. Okay. Number. The second one, B, 8 is the longest side. 3 plus 4 is 7, which is less than 8. So no. Not only is this the shortest lesson in this unit, it might be the easiest one, at least so far, I think. It's interesting because I feel like this unit started off quite challenging and it's kind of progressively gotten not as challenging. Not that it isn't challenging still, it just, I don't think it's quite as hard as it was. All right. Good so far? Like I said, this is like the shortest lesson of this entire unit because, well, this is the only other page. So we're like over halfway through already. So when the two lengths of two sides of a triangle are known, the third side can be any length within a range of values. This is where this lesson gets a little bit more challenging. So it says a delivery company uses drones to make speedy deliveries around the city. A drone leaves the home office and flies 8 miles east to its first delivery, and then 4 more miles southwest to a second delivery. What is the least possible whole number distance the drone will fly to return home to the office? Packed question here. So let X represent the length of the third side. Set up and solve for each of the 3 triangle inequalities. So this time, we don't know which one is the shortest and the longest and the medium length. And so we do have to test all possibilities on this one, which is why there's 3 different problems written. We know 2 sides of a triangle. We have 8 and we have 4. We can't use the Pythagorean theorem. Why not? Why can we not use a squared plus b squared equals c squared on this to figure out the length of the third side? Any thoughts? What's the only kind of triangle the Pythagorean theorem works with? A right triangle. Okay. Do we know if we have a right triangle or not? No. So if you're trying to find out possibilities for the length of a third side of a triangle, it's not as simple as just using the Pythagorean theorem because we don't know if we're dealing with the right triangle or not. What we do know is that the value of x, if x is the longest side, then x has to be less than the sum of 4 plus 8. 4 plus 8 is 12. So if x is the longest length, x needs to be less than 12. If x is either the shortest or the middle length, x has to be greater than what? If we're solving an inequality here, we have to get x by itself. So what needs to happen to get x by itself here? Yeah, minus 4. Which means that x has to be greater than 4. This one would be what? What would x be greater than on this one? Negative 4, right? Okay. Does negative 4 make sense for length? No. Okay. So this one doesn't make sense. Basically what we're saying is 8 can't be 8 can't be put together with x and have 4 be a third side. It just doesn't work because 8 is already greater than 4. So it's just, that's not going to work out. So this one here, if you get a negative number, it's not going to work because negative length isn't a thing. So what we're saying here is there are possible values of x that have to be more than 4, but they also have to be less than 12. So there's a range of values that that third side could be, depending on whether or not it's the longest side or not the longest side. Let me ask you this. Is it possible for x, that length of x, can it be the shortest side? Could x be the shortest side of the triangle? No, because the shortest side would have to be, if x was the shortest side, it would be less than 4, right? But if something is less than 4, it can't add up to equal more than 8, which is why this one doesn't work. We just showed that right there. So that's why x can't be less than 4, which means it can't be the shortest side because the shortest side is 4. It has to be 4. So either x is the medium length side or it's the longest side. Like logically, does that kind of make sense? Like it's either the middle length or the longest length, but it can't be the shortest length. So it's saying that the least whole number value between what and 12? What's the smallest value we're saying x has to be more than? 4. So the smallest whole number value, and it actually asks us right here, what is the least possible whole number distance the drone will fly to return to the home office? The smallest whole number value between 4 and 12 is 5. So the drone has to fly at least, what's the shortest distance as a whole number? 5. Shortest distance it can fly is 5 miles to the home office after the 2 deliveries. What is the longest whole number distance it could fly? So if it equaled 12, I don't know if that would work as a triangle because it needs to be, it says it needs to be x needs to be less than 12. So what would the longest distance it could fly be as a whole number distance? What's the whole number that's less than 12? So the longest distance it can fly has to be less than 12 miles. So what whole number is the whole number that's right below 12? 11, yeah. So the shortest whole number distance it can fly is 5 miles. The longest, which is not part of this question, I added that in, but the longest whole number distance it could fly is 11 miles because it has to be less than 12. So, oh yeah, hey, look at that. That question actually is there. What is the greatest possible whole number for the third side? 11 miles. Let's write that. 11 miles. I didn't even see that there. Cool. 2 more quick questions, and then we're out of here. Not out of here, but we're done with the lesson. Home improvement. Okay, questions on this one? Great. To install a smart thermostat, Kelvin is cutting a triangular hole in the wall. What would you be doing that? Triangular hole, that's weird. Anyway, I guess it works for this problem. He marks side lengths of 2 1/8 inches and 2 3/16 inches. All right. What assumption do you need to make to determine the range for the measure of the third side of the hole? A, the triangular hole is not equiangular, which it can't be equiangular because equiangular means it's equilateral, right? Equilateral and equiangular go hand in hand. And equilateral means what in triangles? All sides are the same, which we know is not true because one of the sides is 2 1/8 and one is 2 3/16. That's not the same. Okay. Do we need to assume that the smart thermostat requires a triangular hole? Not necessarily. Kelvin measured the side lengths accurately. 2 sides of the hole are longer than the third side. So which of these is an assumption? Let me ask you that. Is this an assumption? The triangular whole is not equiangular? Are we assuming that? Or do we know that? We know that, yeah. This is not an assumption. This is a fact. Because if it's not equiangular, then it's not equilateral. This is not equilateral, therefore it's not equiangular. So we don't need to assume that. We know that. What about D? Two sides of the whole are longer than the third side. If we're talking about a triangle, two sides of a triangle have to be longer than the third side for it to be a triangle, right? So D is also a fact. It's not an assumption. So do you need to assume that the smart thermostat requires a triangular hole? Or would you need to assume that Kelvin measured the lengths correctly? I would say the measurements are correct would be the assumption that needs to be made, yeah. I don't think we need to assume that the smart thermostat requires a triangular hole. Maybe it does, maybe it doesn't. That's not really relevant to the math, though. What is relevant to the math is that the side lengths are measured accurately. It's also relevant that it's not equilateral or equiangular, but again, that's a fact. That's not an assumption. It is also relevant that two side lengths of a triangle are longer than the third side. That is relevant as well. But again, that's not an assumption. That's just a fact about math. And so the assumption here would be C. So what is the possible range of the third side? That's going to be done with the math that we just did up here. So we're going to have three problems, three inequalities to work through, just like we did up here. Two of which are probably going to be valid, one of which probably won't be. So let's work through these real quick. I'm going to do the math off to the side because we actually have room up here. So let's just add the two that we have together. 2 1/8 plus 2 3/16. So let's do that. 2 1/8 plus 2 3/16, not 1/16, 3/16 has to be greater than X. You're welcome to use your calculators to do the addition if you want to. It should be 4 5/16 though, right? Anybody have those already? 2 1/8 plus 2 3/16. 4 5/16 is what my brain is telling me, but sometimes it's wrong. Yeah, 4 5/16. By the way, you're welcome to do this on the calculator as well. There are a few different ways you can type this in. So if you go with a mixed number, which this is, you can actually type a mixed number into these calculators. If you look above the fraction button in green, you've got U and then N over D. U is the whole number, numerator, and then denominator. So if you type in second and then the fraction button, you'll get yourself a mixed number. And so the first number was 2 1/8. And we can say plus, type that button again, 2 3/16. 2 plus 2 is 4, 1/8 plus 3/16 is 5/16, which gives us 69/16. But if we want to convert that to a mixed number, that would be, if you see this little N over D with the arrows and then the U N over D, if you type in second and then hit that button and then enter, that will give you the mixed number, which is 4 5/16, which in terms of measurement makes more sense than 69/16 does as an improper fraction, because if you're measuring something in inches, having the whole number for inches and then the fraction of an inch makes more sense. So 4 5/16. Which means that the length of the third side, needs to be less than 4 5/16 inches. 69/16, yeah.
Oh, okay.
That's right. But to get 4 5/16 from that, so if you type in, if you get 69/16, which you should have on your calculator right now, if you want to change that to a mixed number, push the green button again. And then if you look over that x 10 to the n power right next to the fraction button, right above that in green, it's got n over d to u n over d. So that's converting it from an improper to a mixed number. And then it gives you the mixed number. And mixed numbers are better for the answer on this one. So the length has to be less than 4 5/16 inches. So then we got to test out a couple other ones. So let's say 2 1/8 plus x is greater than 2 3/16. What would we do here to get x by itself? I think I heard it. What is it? Subtract. Yeah. Subtract 2 1/8 from both sides, which means the math is actually subtracting 2 1/8 from 2 3/16. That should just be 1/16 when you subtract that. Try it out on your calculator if you need to, but pretty sure that's what it ends up being. Because what is 1/8 written in 16ths? If you were to convert 1/8 to have a denominator of 16, what would it be? What do you multiply 8 by to get to 16? 2. So you multiply this fraction by 2 over 2. So you can say minus 2 1/8 here, and then minus 2 2/16 over here, because those two things are the same, but we're just using the common denominator version of both of them. So that cancels. The 2's cancel, and then if you subtract 3/16 minus 2/16, you just get 1/16. So x is greater than 1/16 of an inch. Now the third thing we need to try is going to be x plus 2 3/16 is greater than 2 1/8. So x plus 2 3/16 is greater than 2 1/8. Do that subtraction and tell me what you get. Did you get an answer when they subtract that? Anybody got it? Negative 17/16. So you got 1/16, negative 1/16. Yeah. Does negative length make sense? No. So this inequality doesn't have anything to do with that problem because you can't have negative length. So what we're saying here, possible side lengths for the third side, the range. X has to be greater than 1/16 of an inch, and it needs to be less than 4 5/16 inches. And we can actually write this as a single compound inequality. What that means is we can just write it all together. You can write them separately, but you can write it together as well. So the way you'd write it together is you'd say that what's the smallest value it can be? Or what's the smallest number? Which of these two numbers is smaller? 4 5/16 or 1/16? 1/16. Okay. So 1/16. And then take a look at what way this arrow is pointing here. The point of this inequality is pointing towards the 1/16, right? The less than side of it is facing the 1/16. So I'm going to say, keeping that point of the inequality, pointing that 1/16, and then x. And then if you look here, the point of this inequality is facing the x. So I'm going to point a new inequality facing the x, and then I'm going to write 4 and 5/16. So basically what we're saying here is that on the low end, we've got 1/16. On the high end, we have 4 and 5/16, and then any values in between those two are valid for values of x. We need one more thing at the end here, though. One more thing that goes after this. Any thoughts on it? What should we write after the numbers? Yeah, units of measurement, inches. Then you can just do IN for inches, that's fine. But if you are using units of measurement, include those units of measurement in your answer. So anytime you're writing a range of values, you can write it like this. The smallest goes on the left, the largest goes on the right, x goes in the middle, and you have two less than symbols separating the lowest to x and x to the highest. So we're saying that 1/16 is less than x, which is less than 4 and 5/16. So all values of x are in between those two numbers. All right, all possibilities for x. We are going to answer this proof, but I'm not going to have you do proofs on your assignment. So we are using the triangle inequality theorem here, and it says it's a three-step problem. So that's why we're going to do it. Triangle HAB and triangle HCB share side HB. And I think that's pretty clear. I don't even think that's something that needed to be written, but they wrote it. HC is equal to HB. Okay, that's important. Prove that HA plus AB is greater than HC. So HA plus AB is here. HC is over here. So those two lengths are not on the same triangle as HC. So that's why we've got a little bit of in between to work on here. So we're going to use the triangle inequality theorem. We're just going to do this one. There's none in your assignment that I'm going to have you do. Yeah. So any thoughts as to how we can kind of maneuver ourselves to be able to get from using the triangle inequality theorem? There's a lot of ways that we could use the triangle inequality theorem, first of all. What is in our diagram that we can mark based off of the given? Are there any markings we could put on our diagram based on what the given information tells us? HC equals HB. What could we do on our diagram to show that? Put a mark, yeah. HC is equal to HB. There we go. So let's think about this for a second. We're trying to show that HA plus AB is greater than HC. HC is not part of this triangle. What is part of this triangle other than HA and AB? No, BC is on the other one. Oh, come on. But HA and AB, what's the third side of this triangle over on the left? HB. Is it true that this one plus this one has to be more than that one? Yeah. So let's write that. Because we would say, we're just going to basically write the same thing as step 3, but instead of saying HA plus AB is greater than HC, we're going to say HA plus AB is greater than HB. What's that? Oh. So this one plus that one is greater than HB. And because HB is equal to HC, that means that HA plus AB is greater than HC, since those two things are the same. So basically, the only thing that's changed between steps 2 and 3 isn't the left side of the inequality, it's the right side of the inequality. What did we do to make that change? If two things are equal and you swap them out for each other, what did you use? So those two things are equal. We swapped them out. What's the reason? If you replace something with what's equal to something else, what is that called? Starts with an S. If you plug something in for something else. There it is, substitution. Cool. That wasn't just super hard proof. Not bad at all. All right. So that's it. We're out of here at 1:42 today. So we have almost 30 minutes. Nice. Nice short lesson.